Right. That's your umisitse class, ne? And jwale o tlo batla go ba thatanyana gore o catch up to ena e re go e buang. But he ke nana ha o ya ka channeleng o tla fumana hona be sebeditse o fitlela kae o etsahetseng because re ntse re le busy ka stoichiometry. Ke gopola hantle maobane ne re dilana le problem just fella for a quick revision. Maobane, we spoke of the following. All right. Hydrogen and oxygen react to form water. Right? And then in a chemical reaction, we do H2 as a gas reacts with a diatomic molecule as a gas to form H2O as a liquid. We balance the reaction. Now we balance the reaction of water. If 3 cubic decimeters of oxygen is used, what volume of water? What volume of water is produced? This was the question, Maoban. And then what we said, Maoban, okay, the first thing that you need to do when they say that hydrogen reacts with oxygen to produce water, and then you are given that 3 cubic decimeters of oxygen is used, what volume of water is produced? The first thing that you need to do here is to balance your chemical reaction. Already necessarily balance it because the reaction is referred. H2 as a diatomic molecule reacts with oxygen also as a diatomic molecule to produce H2O. Now, before we can do anything with that, we need to balance the reaction because we need to deal with the stoichiometric coefficients of that which is of interest. Hydrogen is balanced, and oxygen is oxygen 1. We need to balance oxygen by writing 2 to the front of this. Let me just try to use different colors so that we see the difference. Right, now how you can 2 more signal oxygen is because 2 remember a multiply and 2 long way come. Signal hydrogen is 2 times 2 to 4, 2 times 1 is 2. So come on, to 2 man. Maybe hydrogen is 4, oxygen is 2, oxygen is 2. Right, you need to balance your chemical reaction. Secondly, I introduce a formula airing VB equals A over B. In fact, VA equals A over B, VB. Rebuaka volume the stoichiometric factors. A and B. Those are the coefficients. Now more the volume of A. Volume what volume of water is produced. So about the volume H2O. A over B multiplied by volume B. Onewe volume in oxygen. So muna itlaba oxygen. Right, then oringu onga the stoichiometric coefficient there A representing volume of H2O. Stoichiometric coefficient there H2O to guy 2. Divide onga stoichiometric coefficient there B representing oxygen. Elembo guy 1. On multiply volume ya oxygen elembo guy 3. When you multiply here, you get 6 cubic decimeters of what? Of H2O. So what volume of water is produced? You will produce 6 cubic decimeters of water if you have 3 cubic decimeters of oxygen. This is something very important that we dealt with yesterday. Right, now how to got this problem. Right. I think we need to interpret this much further. Now, we interpret, let me just write here to say that we can interpret the chemical reaction. We can interpret the chemical reaction in this example as follows. Alright, this reaction here, 2H2 as a gas plus O2 as a gas, producing H2O also as a gas. Regarding we can also say 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of water. This is one interpretation. We can also say that 2 volumes of hydrogen react with 1 volume of oxygen to produce 2 volume of water. This is another way of interpreting this chemical reaction. You can say 2 moles of hydrogen reacts with 1 mole of oxygen to produce 2 moles of H2O, or you can say 2 volumes of H2 reacts with 1 volume of O2 to produce 2 volumes of H2O. Because of what now? Because of this direct proportional relationship between mole and volume. This is something we spoke about yesterday in a class. Now, today I wanted to attract your attention to what we call a gas phase calculations. This is what I want us to look at. We will be looking at a gas phase calculations. So come on, the reactions of gases. Now, suppose what volume of oxygen? What volume of oxygen at standard temperature and pressure? All this had been dealt with in the previous 2 lectures. What volume of oxygen at STP is needed? Is needed for the complete combustion of 3.3 cubic decimeters of propane in C3H8. Kinana organic chemistry. We will deal much with the combustion reactions, but for now, propane as a fuel in the chemical formula C3H8. Yeah? So come on, there are 3 carbons for every 8 hydrogen atoms. So come on, it is a hydrocarbon. My father. Now, what volume of oxygen at standard temperature and pressure is needed for the complete combustion of 3.3 cubic decimeters of propane. Now, the first thing that we need to do here is to write down the chemical reaction, balance that chemical reaction, write down the stoichiometric factors, and find the solution. So now, now the first thing is to write down the chemical reaction. Right, what volume of oxygen at STP is needed for the complete combustion? Now, key of propane. Okay? So, come on, C3H8 in the presence of oxygen. Okay? To produce carbon dioxide plus water. This is the product of a combustion. Whenever a fuel is in the presence of oxygen, it will always produce carbon dioxide plus water. Yeah? Right. So the first thing that we need to do more is to write down a balanced chemical reaction. And then what is this? It is a fuel again as a what? As a liquid, this as a gas, carbon dioxide as a gas, and H2O as a liquid. Okay? Alright, so regarding in this reaction, but how reading as the gases? How reading as the gases, because monading also as the gases. Now, the first thing that we need to do is to balance the chemical reaction. How do we balance this reaction? C3H8 burns in the presence of oxygen to produce carbon dioxide plus water. Let us try to balance this. How much carbon? Carbon is a taru, carbon A1. Again, how to balance a carbon? But I'm going to 3. Again, carbon is balanced. On a hydrogen it's 8. On a hydrogen it's 2. Making 4. Again, about 8. Another oxygen is 8. Marikaman another oxygen is 6. Again, 6 plus 4 is 10. So you can have 5. Because 5 times 2 is 10. 3 times 2 is 6. 6 plus 4 is 10. Sharp, okay? Now that the chemical reaction is balanced, the second thing is to introduce the formula. Okay? A ring VA equals A over B VB. What volume of oxygen? Volume of oxygen A over B multiplied by volume of what? What volume of oxygen at STP is needed for the complete combustion of 3.3 cubic decimeters of propane? C3H8. Okay? Right, now what is the stoichiometric factor? Oxygen. 5. What is the stoichiometric coefficient B in C3H8? H8. 1. We multiply the volume of C3H8. We will 3.3. Nginyetse ntona calculating on PV. Nginyetse ntona calculating on PV. Akusibela ba yabona ha? Ha yabona. PV. 16.5 cubic decimeters. That will be the volume of oxygen gas. That's a sharp.
Every time you have to
a balanced chemical reaction.
Answer equation. Finally interpretation.
Way. But we are just interested in this answer. We're not going to conclude that therefore 16.5 cubic decimeters are needed at STP for a complete combustion of 3.3 cubic decimeters of propane. But final answer, the correct. Happy to use the formula, the correct manipulation, the correct answer. But look at the previous question paper, although one of the memorandum so that you are in line with the way they approach things. So you don't have to stress yourself. Magagahan. Hey, Galebo. Right. Eriko leak. Eriko leak. I want to know fast. Copa fashion sell cop. Get like Fatamara. Right. Potso ke ena wena ka se. Ho thwe ho rona. Ho pole no ke di basic fela. Ke di basic mara tse ke neng tsa hlala ka exam but re tlo etsa di question paper.
Dosa.
Kena na utlwa hosane in fact o kwa bekeng ya Mantaha because ngola la bona ke. Ngola la bedi.
Ngola physics la bedi.
La bobedi.
La bedi Mantaha ntho la go go ngola bedi.
Si ngola physics ni.
La bedi.
O itse o ya ka kwana na goma.
Mo
Mane di rehearsal ngole.
Aka 12 ke tsa makukuta.
Oh okay. Hosane
Sane ke re ke
ke tswa ka level.
mo tla be le free tsa.
Re tlo tlameha re kopane ntate le ngwana no tla ba le teng ngwana wa khutla hosane from Durban or somewhere. Re tlo tlameha re kene re tle re betse di question paper ho ya le kwa le Mantaha. O ngola la bobedi physics. Ke stoichiometry ke Boyle's law again. No di shebe mo. Ke batla ho nketsetse this one. Ho thwe methane burns in the presence of oxygen. In the presence of oxygen. Quantitative aspects of chemical change. Ideal gases
and thermal properties. Energy and chemical change.
Alright.
Acids
Acids and
and bases.
bases, yeah. Say the chapter ya quantitative aspects of chemical change. Boyle's law re-ins. Re tlo tlameha re kene ho acids and bases. I think hosane late. Jwang kapa jwang. Re tlo tlameha re kene ho acids and bases re lo bua ka bo Arrhenius model, re lo bua ka bo limiting reagent le bo excess reactant. So now re tlo di etsa hona mona ho quantitative aspects of chemical change. And then I think we will have enough time. Because le bana ba ngola mmetse la bobedi le bona. So Mantaha wa tseba re tlo etsa. Le tlo tlameha le kene habedi. Tlo tlameha le kene ka 2 until ka 3:30. Be ba kena ka 3:30 until ka 4:30. Then if le khona o kena ka 4:30 until 5:30, then it's fine. I think it will be fine. Methane burns in the presence of oxygen, forming water and carbon dioxide. Okay, according to the following reaction. According to the following reaction. Right, CH4 as a gas burns in the presence of oxygen, producing carbon dioxide plus water also as a gas. Right, so everything is in a gaseous phase. Now, if 4 cubic decimeters of methane is used, what volume of water is produced. I think the same procedural method will be employed because this is just a repetition of the past question that we have dealt with. Now, the first thing, remember, is to balance the reaction. So, balance it is CH4, O2, carbon dioxide, plus water. How do you balance and tweak it?
Although we are 2 go each, because each is 4.
Okay.
C, oxygen dipedi.
CE1, CE1.
Oxygen dipedi. Not allowed to send to you.
Hey, can you say oxygen?
No. Hey, oxygen
Dipedi kamu.
agak bedi di
Kamu na di 2, 4.
di 4. Agak kamu kena 2
Then keeping 2 more. Okay? Right. Then from there, after introduce the formula, okay? VA equals A over B, VB. Okay? Now, okalagan tuba what volume of water? H2O, A over B, volume of that which is provided, methane in CH4. Okay? Alright, what are the stoichiometric coefficient of water? K2.
H2 2.
Icon. H2O, K1.
Actually, rebalance.
Askis, rebalance into 2. Askis. And then stoichiometric coefficient methane.
K1.
Okay? And multiply volume ya CH4, which will give 4. And then you offer 8 cubic meters again of H2O. These are just questions the test and links. Now, I get a little bit deeper here. Given the following equation, on a way equation, what beryllium as a solid reacts or bends in the presence of oxygen to produce beryllium oxide also as a solid. Now, also array balance are based on a chemical equation based on the periodic table. Looking at the 2 more. How many moles? How many moles of beryllium? How many moles of beryllium oxide can be produced? Can be produced from 0.44 moles of beryllium. People, how many moles of beryllium oxide can be produced from 0.44 moles of beryllium? The second question, how many moles of beryllium oxide can be produced from 0.71 moles of beryllium. The third question, how many moles of beryllium oxide can be produced from 0.71 moles of beryllium, right? How many moles of beryllium oxide can be produced from 0.44? moles of oxygen. Oxygen in O2. The third one is very 0.71 moles of beryllium and 0.44 moles of oxygen react to form beryllium oxide. Right. Use your calculations above. To decide which is the limiting reagent. Use unrounded values. This is the question. We are just going a little bit deeper. Beryllium as a solid reacts with oxygen gas as a diatomic molecule to produce beryllium oxide. So we need 2 berylliums for every 1 oxygen, because oxygen is in group 16 and it has a valency of 2. Whereas beryllium is in group 1. It will need 2 berylliums to react with those electrons oxygen. And this has more electronegativity than beryllium, therefore it will pull the electrons towards itself. But that's another topic for another day. But how many moles of beryllium oxide can be produced from 0.71 moles of beryllium? How many moles of beryllium oxide can be produced from 0.71 moles of beryllium? And then I want to look at this direct relationship between volume and moles. They have a direct proportional relationship. When volume is bigger, there are more number of moles. If the volume is smaller, there are lesser number of moles. There is this direct proportional relationship. So how about but when how many moles of beryllium oxide can be produced from 0.71 moles of beryllium? I think you're going to treat it the same as this. Or going to treat it the same as this and tell me how many moles there will be. Instead of volume, it's a number of moles.
What do you V a little bit?
What do you V? A. But in terms of the same stoichiometric factors, depending on how the same procedural method. Oko is a memo kibonena itawo beaka. Oko is a memo kibonena itawo beaka.
Ke 0,71
0,71.
moles.
Harebo. Solution. The first one. How many moles of beryllium? So let's use a formula. Na equals A over B N B. Okay? Because of this direct proportional relationship between number of moles and volume. So the A ibatuwang, how many moles of beryllium oxide? Number of moles of beryllium oxide, A over B, number of moles of beryllium. Okay? Now, stoichiometric coefficient ya beryllium oxide ke 2. Okay? And then in the stoichiometric coefficient ya beryllium ke 2. I multiply a number of moles of beryllium.
0,71.
0,71. You offer 0,71 in moles. Aye, Jesus, my Father. I get it? Right. And then area number 2. How many moles of beryllium oxide can be produced from 0,44 moles of oxygen? All right. How many moles of beryllium oxide can be produced from 0,44 moles of oxygen?
But Papa fella
I don't chat. Re ke tse fela pause. I ke kopa fela go ira pause. I think we fumane ne
0,88 moles.
0,8. Right, how many moles of beryllium oxide? Okay? So moles of beryllium oxide, A over B, number of moles of oxygen gas. Okay? Right, stoichiometric coefficient ya beryllium oxide, 2. Stoichiometric coefficient ya oxygen, 1. Okay? Okay, multiply a number of moles of oxygen gas. Okay? 0,44. Equal for 0,88 moles. Okay? Right, and then from there, Beriakan. Question 3. Now, mole number 3. 0,7 moles of beryllium and 0,44 moles of oxygen react to form beryllium oxide. Use your calculations above to decide which is the limiting reagent. Already we have the answers, okay? What is 0,71 moles of beryllium and 0,44 moles of oxygen. Okay? Right. React to form beryllium oxide. Remember, has 0,71 react 0,44. Di produce ya beryllium oxide 0,88. Now, use your calculations above to decide which is the limiting reagent. Use unrounded values. Round off again. So, which one is a limiting reagent between beryllium and oxygen gas? A limiting reagent, ki felang before a how only a limiting reagent, how a reaction is stop, when a limiting the reaction. Number enyani ke yone e limitang because ke yone e tlo fela pele. So between beryllium le oxygen gas, which one is a limiting reagent?
Beryllium.
Beryllium. Beryllium worth bokae kan?
0.71 moles.
0.71. With 0.71 moles is the limiting reagent. So kama ntomang yona ha e fela, the reaction ya stop. So beryllium with 0.71 moles is the limiting reagent. Unfortunately, ne ke preparile lesson ya hao go fitlela fela mo. That's